the last two lessons that we are going to talk about in this unit have to do with something called volume, okay? And volume is like the amount of space, essentially, something takes up. Or maybe I'll put the amount of space inside of a figure. Okay, so if you think about what we need to know, if I want to know, like if I've got this rectangular prism, for example, and I want to fill it with like water or something, I need to know, first of all, like how much space would go on the very bottom layer, right? And that would be the area of the space. And then I would keep taking that and filling it all the way up to the top. So the formula for volume, and the good thing about like the prism and cylinder is that the formula is the exact same. You just have to be able to understand like what the base is for each figure. And so the formula for volume is the area of the base, right? How much space would go on that bottom layer times how tall the figure is. So that's what these variables stand for. The capital B is the area of the base. And then this is the height of the prism. Now, what is important here, and I kind of mentioned this when we talked about surface area, determining what the bases are in a prism. So if you're looking at like a rectangular prism, remember the bases of any prism have to be congruent figures that are parallel from each other. So in a rectangular prism, most of the time we just think about the base as being the side that your figure is sitting on, like a Kleenex box or something. And that's okay because we've got this rectangle down here and we've got a congruent rectangle up here. But I could also turn this figure like this and then make this the base. And then I could also flip it like on its front, and that could be the base. Because if you have a rectangular prism, it doesn't matter how it's oriented, you'll always have a congruent and parallel rectangle on the other side. And so what you have to remember kind of goes about the height, kind of goes back to what we talked about like with trapezoids and parallelograms. Depending on what side you call the base, the height is going to be different. So the height is always the distance between bases. So it's not necessarily, especially for triangular prisms, it's not necessarily always going to be like the vertical part, and we'll look at a couple examples of that. So it's the distance between bases. Okay, all right, and so with this particular rectangular prism, we need to figure out the area of the base and we need to figure out the height. Well, the area of the base is going to be 10 times 5 because it's a rectangle. So formula is length times width, or base times height. So 10 times 5 is 50. And then the height, the distance between the bases, would be 6. And so that means that my volume is going to be 50 times 6, which would be 300 inches cubed. Okay, so when we're talking about volume, your units are now always going to be cubed. The reason for that is because if we think about what the capital B stands for, it's area of the base. So the area of the base is technically 50 inches squared, and the height is 6 inches. So when we take inches squared times inches, we get inches cubed. So that might be another thing you want to add up here. You're always going to be looking at cubic units. Okay. All right, and so that's it. That's all you have to do. For this one, this is a triangular prism, and we have to just be careful about what we make sure we call the base and what we make sure we call the height. Now this one is pretty easy because your prism is actually sitting on the triangle. So we know that these two triangles are the bases. And then the height, that distance between, would be that 2.9 centimeters. I'll show you an example on a different worksheet about like what we'd have to take into account if this weren't sitting on the triangle. And so to find the area of the base, since it's a triangle, it's going to be 1/2 times the length of the base times the height of the triangle. So if you want to draw it out, this is a right triangle. That's 2, that's 6.4. So I don't need to do the Pythagorean theorem or anything. I know both pieces that I need. 1/2 times the length of the base times the height. 0.5 times 2 times 6.4 is 6.4. And we said the height was 2.9. So the formula would be area of the base, which is 6.4 times 2.9. So again, it's the same formula, but the area of the base has to be the formula for the area of that polygon, whether it's a rectangle, a square, a triangle, whatever. So 6.4 times 2.9 is going to be 18.56 centimeters cubed. All right, so what I was referring to before, if we were to look back, for example, at this problem from the surface area node outline, when we look at this, the base of this figure is not 48. This rectangle here is not the base of the prism. Okay, hold on 1 second, guys. Go ask Daddy, honey. Okay, well, you're gonna have to wait. Oh, sorry, guys. Oh, apparently one of his army guys fell behind his bed. I'll be up in 5 minutes, okay? And so the rectangle is not the base. The base will be these two triangles. The reason it's not the rectangle is because there is not another rectangle that is congruent and parallel to that. So you have to make sure you understand that the triangles would be the two bases, and kind of think about that triangular prism like sitting on the triangles. So the area of the base would be that, and then the height would be the 4 inches, not the 5 inches. Okay, so that's one thing that's can be a little bit tricky about volume compared to surface area, is making sure that the figure that you're using for the base is actually the base and that the height is actually the height. Okay. All right, and so this last one for prisms, before we move on to cylinders, we're just going to do a little extension problem here. So this is a pool is in the shape of a cube. Okay. A cube is a special type of rectangular prism. Think like a Rubik's Cube. That basically means that you've got a prism made up of all squares. Okay, so every side is going to be the same length. And we know that the volume is 1,728 cubic yards. So it says the pool's owner needs to paint the cover of his pool. If the cover of his pool fits exactly on the top, what is the area in square yards that the owner needs to paint? Okay, so back when I was in school and I doodled in class, I mastered how to draw a cube. Yes, it's been a while, so it's a little bit off, but you get the idea. And so all of these sides, again, are going to be congruent since we know that it is a cube. Well, if the formula for volume, since this is a rectangular prism, is area of the base, so length, base times height, sorry, and then times the height of the prism, well, if all of these are going to be the same, since it's a cube, that means I'm just going to assign the variable x and cube it, right? Because that's going to be the same, that's going to be the same, that's going to be the same. and I know that that volume is 1,728. Okay, so we need to figure out what number times itself 3 times is 1,728. So you could guess and check, like 6 times 6 times 6. That's going to be way too low. So maybe 11 times 11 times 11. That's still too low. So maybe 13 times 13 times 13. That's too high. There we go. Okay, so it's 12 times 12 times 12. You know, that took me 30 seconds to do, but you're also not necessarily going to be looking at whole number answers. So every calculator has what's called a cube root button. Here's the calculator that most of you guys have. So we are so used to doing square root, which is above the x squared right here. So we usually hit second and then x squared to get to the square root. Above that is another radical, and it has this x in front of it. So you can type in before you hit that whatever you want to take the root of. So since this is being cubed, we want to make sure we take the cube root to undo that, just like we would take the square root if we wanted to undo the square. So you have to type in a 3 first, because we want the root to be 3. And then I would hit that, and then you just type in that number, and you still get 12. Okay. And so if that means that each side of this pool is 12 yards, that means the area is going to be 12 times 12, which is 144 square yards. Okay. Now, we're not going to be doing a ton of these extension problems. Again, just in this situation, we're going to kind of just make sure we can get the basics down. But I did want to show you an application of how this is used. This unit in particular is one that I really wish we were in school for, because this is definitely like one of the most applicable units to things that you will use outside of this classroom. You know, are we really going to use special right triangles that often? Probably not, but surface area, volume area, yeah, definitely. Okay, all right, and so the volume of a cylinder, the idea is the same. If I need to know what I would need to fill this, I need to know how big the base is. That would be the area of the base. And I need to know the height. How many times am I going to do that? So like the basic formula is the exact same. Area of the base times the height. However, since we are talking about a cylinder, the area of the base is always going to be the area of a circle, because the base of a circle, or the base of a cylinder, is always a circle. That's why we didn't get too specific with this one, because the base could be a rectangle, the base could be a triangle, the base could be a hexagon, and we're not going to go quite to that level, but the base could be any sort of polygon. But if you're looking at a cylinder, the base is always a circle. So the formula, if you want to break it down a little bit, is pi r squared, area of the base, times the height of your cylinder. Okay, so again, make sure that you're using the correct orientation. Like if this cylinder had been turned on its side, the height would not be 16 inches. The height is always the distance between the bases. Okay. So the height is always going to be the distance between your circles. So we're going to practice finding, again, exact and approximate volume. So the area of the base is going to be pi r squared, and then the height is 6. So how much is that bottom layer? How many times do I have to get there? So 64 is 8 squared times 6 is going to be 384 pi inches cubed. That would be my exact answer. No rounding involved. So just like with surface area though, and consistency purposes, we're going to use 3.14 for pi. So I'm going to get 1205.76 inches cubed. Here's Another similar problem, I kind of put the height just in a different spot, but it's still the same thing. This 4 feet is the distance between your bases. The radius is 3. Really, the only extra work you would ever have to do if you were looking at cylinders is cut the diameter in half to get the radius. Cylinders are usually the easiest of these figures. So we're going to do pi r squared h. 9 times 4 is 36 pi feet cubed. There's my exact answer. 36 times 3.14 is 113.04 cubic feet. That's it. Okay. So last problem is again just another little extension, a less basic problem than this one. So again, we're given the volume. We're given the height. I want to figure out the radius to answer this question. Okay, so my volume is 4561, and I know that the area of the base is going to be pi times r squared, so I'm just going to keep it r. You could call it x. And then the height is 12. Okay, all right, so I'm going to go ahead and I'm going to start by dividing this by 12. Okay. So that's going to give me about 380. I'm going to round this out just a little further, just to keep this a little bit more precise at the end. Okay. I'm trying to get the r by itself, so the next thing I'm going to do is divide by pi. And again, we're going to use 3.14, so I'm just going to hit divide by that. So I'm going to get 121.0456476. Again, usually the reason why I'm writing this whole thing out is again just to keep the answer as precise at the end, since we are already rounding to begin with. And then here I'm just taking the square root, so you don't have to go to that other button. We can just use the basic square root. So the square root of 121.0456476 is actually just going to round to 11. It's not exactly 11, but so I'm going to put the approximating symbol right there. Okay. All right, and so that is volume for prisms and cylinders. So your homework tonight, you'll recognize the problems. The first 4 are the exact same problems from your first assignment, except you're finding volume and not surface area. And then I replaced that last question with a volume question instead of surface area. So as always, just let me know if you guys have any questions. Bye.